we're out here on the floor. Luis is putting the logo on the back side of the part. Look how nice that's coming out. More to come. I'm going to verify the part program right now. Oh yeah. Alright, now we're going to go and deburr the profile. Oh yeah. Oh yeah, that's going to look nice. Alright guys, the Luis has got the program just about ready. Let's go in here and do a simulation of how the machine is going to make the part. You come in here with a 1/2-inch end mill. Hog all that out. Put part number in. I don't think the part number is big enough, Luis. Can you make it 6 inches tall?
Yeah, I'll try to go 100 thou deep and about 6 inches tall.
There you go. Let's see.
Something's wrong with that last operation.
Wrong side of the tool?
Might be. Yep.
Yep. Just got to put it on the right side of the tool. Almost there. All right, so it's giving us a little hassle, but we got her done. Let's check it out. Oh yeah, it's looking good. That yellow tool path just means that's the one you have selected. Oh, she's looking good now. Now we just got to get her cut out. Right on. Here's how it's gonna look going into op 3. Now on 3, we're gonna cut the profile, finish the profile, and there you go. That's how we program it. Now let's see if we can machine it. Oh, ain't that sexy. Nice work. We're out here squaring up the block right now. I think Michael's just going to do it manually. Go ahead, just do your thing. I'll film around you. What we're doing now is we're squaring up the sides of the block to ensure that all the sides are dead square, so that when we machine the fixture, we are, everything's going to be just right. We're out here with Luis now, and what he's doing is we're touching off the tools. Okay, you see how he's going to go down there and he's going to touch that tool to that surface. And we like to use a 1/1000 shim, and he's going to move and click some 1/1000ths on the hand wheel until it stops moving that shim paper. All right, and that puts you within 1/1000ths, which is usually going to be okay. See, and now he just set the tool. And what he's doing when he sets the tool is he's putting in this number right here. All right, this number is how far away that tool tip is when it touches the top of that part from machine home. That's what this number means. All right, so he's going to go load tool 10 now and set tool 6 rather. So also wanted to mention that you see how we have a stop block here. All right, the machine also needs to know where this corner is, because this is the corner we programmed from, because this is on the solid, this is the movable jaw. All right, this is the solid jaw, it doesn't move. The stop doesn't move. So what we do is we go and touch off the X offset here and the Y offset here, so that the machine knows where the part is in 3D space. And this is where that information is stored. That's the tool offset. This is where that information is stored. The G54, which is normally the first offset. Now in the X, it's minus 18.114 away from machine 0. And 5.638 away from 0. All right. Now machine 0 is over in this corner, I believe. It's over in this corner, I believe, on this machine, and that's how far away it is from this back corner of the machine to here, and that's called an offset. And we use that to tell it where the part is. All right, there's off 1. Oh, nice and sexy. Let's see what we got. Ooh, looking good. Oh yeah. Couple more pieces, let's get it on the truck. Here we are making the blocks. We already made the upright. There was 10 of them laying here. Oh, look at there, look at there. Very nice. There's our little block. We're rocking and rolling this morning, boys. It's Christmas Eve. We're gonna have this done. Good morning, guys. It's the day after Christmas. Hope everybody had a great holiday. Oh, let's turn the lights on and let's get back to where we're at. See what's going on. All right, so this is where we're making all the parts. Looks like we are on, looks like op 1. We still gotta put it up on its side, put some holes in it, and face off the back side. Looks like our clamp blocks are ready. Looking pretty nice in there. And this is our 56 millimeter rear support. Shiny and nice. I'm liking this. Project's going pretty good, and looks like, well, I kind of wanted you guys to just share with me with a quiet shop real quick. I love a nice quiet shop in the morning. I love it more when it's crunk up and running and producing money to pay the bills, but I love a nice quiet shop in the morning. There's a certain smell. We don't have smell-o-vision yet, but there's a certain smell in a machine shop before the coolant gets flowing. It just seems like home to me. Back here, this one's broke down right now. We got to pay Haas $200 an hour from when they leave their house to come fix it. But we got a really good service guy, and he does a great job. So we'll get back on the video when Michael comes in later today. I'm going to get the shop fired up. Next step in what we got to do, and I've already went and opened the file up. Next step in what we got to do is I got to get this hole pattern exported out to either SolidWorks or Mastercam or an IGES file or something, because my dad's a Gibbs Cam guy. I'm a Mastercam guy. We meet in the middle at SolidWorks. That's why we have all 3 systems. So what I'm going to try to do is do a file, save as, and we'll change the file type down here. Nope, that ain't how you do that in Gibbs Cam. I have a working knowledge of it. I don't use it very much. Oh, export. I don't use it very much because when you draw in Mastercam, everything is really hard in Gibbs. It's a very unique system. It works really well. I just don't like it. So let's go out to an IGES file. That's let's see how good my brain works. International Graphic Exchange System. Haha, I did remember it. That's old school, but just about any kind of CAD or CAM system will read an IGES file, so I keep it easy and use that. Back in my office now, and I got this pulled in SolidWorks. As you can see, it's a little bit messy, but all I really got to do is, let's go over here and look, grab the car. So what we got to do, I already got the block off of it. What we got to do here is, okay, so what we got to do here, sorry, I'll cut some of that stuff out. Okay, we got our block, right? And we need another hole here. Okay, and we're way out at the end of travel now, but we got our hole here, and that should be about at the end of travel here, right? And we need another hole over here, which Yes, that will interfere with this part of the side guard. So yeah, we're going to need to do some considerable side guard trimming in order to get this system going. But what I'm going to do is I'm going to take the same dimension from hole to hole on the block, and I'm going to use what looks like the second hole in the current rear support pattern. I'm going to use that second hole, and I'm going to go over here and what I'm going to do is, oh, I forgot to look and see what else we got. See, we need to look at the bottom of this. That ain't gonna fall off. Okay, looks like, because you see I gotta find a pattern. All right, because we need to make a template, and I think I'm gonna go here and here, and then we'll have a template that you'll lay on the bottom of your chassis. You'll have to take that. You'll have to take this this support off. All right, and you'll have to take your current battery tray. I believe these are battery tray bolts, but you ain't gonna have, no, that's not battery tray, is it? What is that? Maybe those are ESC bolts, ESC plate bolts, because the battery tray, I don't remember on the stock model, to be honest with you. Oh, battery tray's over here. I deal with a lot of chassis, guys, cut me some slack. Okay, so we'll use this hole, which is probably old ESC plate hole, and this hole, which is side guard hole. But yeah, I want to get as close as I can. Or what if I use this hole and the center brace hole? I don't know. That's a lot of stuff to take off. It's going to be easier to take off the side brace right here. Most of you guys got metal ones anyway, but the side brace, if I remember correctly, the side brace comes off independently. So that's only 2 screws to remove. That's the pattern we're going to use. So you'll have to take out that screw, this screw up here, and then we'll use this screw, and then since we got a screw there, we might as well use that one. And then we'll have 3 points of contact for you to drill the hole you need to drill out here. Actually, come here to here. We don't even need that. All we need is 1, 2, and then we're going to drill a hole right there. And I'm going to give you guys a special drill. All right. So let me get over here and draw it and print it, and let's check it out. That's what I came up with for a template. It's going to work pretty good. I'm going to go ahead and print one of these. It's going to be a slam dunk to install this thing, guys. I mean, it's going to be a nothing installation. Let me go ahead and get this thing extruded into a solid. It's real hard to film and work at the same time. So I'm going to try to show you how we make this little extrusion. We're going to go here, and then we're going to go features, and then we're going to say extruded, and we're going to make this thing, let's say, 1/4 inch thick. We'll say, I'll make it 1/4 inch thick, right? And then we'll go and extrude that. And then let's go and turn this sketch off so we can see what we're doing. And there's our little part. There's our little template. So what we're going to do is we're going to, well, I'm going to show you guys. I'm going to go ahead and do the install video, and then I'll make the install video part of this video. And we'll get to it. I'm going to bring it over into Bamboo and print it out, and we'll get back to it. I almost forgot to label this. So I went in and I put some text on this thing because the way we're drawing this, I'm going to cut that into it. So the way we're drawing this is, here's our chassis, right? Here's our chassis, and I know that we're looking at the bottom of the chassis because I can tell from the direction everything's in, and I can also, we just put engraving on it. So the engraving is letting me know that we're coming from the bottom of the chassis. So I'm kind of I'm drawing this from the bottom of the chassis. So, but if you flipped it over, it'd be the wrong way. So I went ahead and put a little label in because this is just going to be a 3D printed part. Should suffice. Hopefully we don't have to make it out of metal. Otherwise I'll have to change the shape so it's easy to make. Alright guys. Why don't I start every video with alright guys. Welcome back fellas. We're going to try this video from this side of the truck because I'm right-handed and I keep seeing myself getting in your way with my arm and stuff because I'm right-handed. So we're going to try it from the left side, see how it works. Hopefully it'll make a better video for you guys. Like and subscribe to our YouTube channel, please. And follow on all the social media channels. Okay, so we just went and printed out the new template. So we're going to do this right on the truck with you guys. So let's take this motor off. Now this should be slam dunk installation, nothing to it. Put that there. We shouldn't have to do anything to this except remove the motor, which is already in our reverse motor mount, and this brace. That's my plan because the hole's going to go about right there. So let's do that. And let's go here. And hopefully I'm going to do it just right so that, oh no, nope, doesn't work like that. Maybe that's a double piece. So, I mean, I'm hoping this is going to be able to double for the installation video because it'd be a bummer to have to make a new one just for this, but that goes underneath that. Let's see. Because, you know, you always want to try to take off as few bolts as humanly possible. Aha! There's one. Success! So, 3 bolts. And you're there. So, you guys I don't think you guys have anything in the way of that screw. So, 3 screws, you remove that. Now, I don't know which size screws. I know it's going to be a 4 mil. We're going to do a couple of 4 mil flatheads. We'll just grab a couple out of the box here. That's a 5. Grab a couple out of the box here. That looks about right. So what we're going to do is we're going to take, now I put 2 chassis. So what we should be able to do is just take, screw this screw. Now I ain't never done this before, y'all, so, and I'll find the right size screws, but this is how shit gets done. You know, you just use what's laying around if you can. Now don't go crazy on the torque. This is just going to be a piece of 3D printed material here. So now, I did make the hole 5 thou oversized. So let's see if my estimation on the hole size was right. A little tight. A little on the tight side. Probably should have checked that before I got there. Now, I'm sure you guys have seen somebody drill a hole before. So, should I do this off camera or bring the trash can up there? I'll cut this part out. But all I'm going to do is drill straight through this template and into the chassis. And then I'm going to take the special drill Alright, I'll of course fast forward through that. As you can see, went straight through there. Now I've got a nice little hole right there. So I'm going to put you guys on pause, and I'm going to go grab a 90-degree center drill that will be included with this kit. So hang tight. All right, so I'm back. Now this is our 1408 kit right here, and this will have a 3mm drill in it, and it'll have this special 90-degree countersink drill. It's called a center drill in a machine shop. Some catalogs and stuff will call it a combination drill countersink. Call it whatever you want. But what we're going to do is, now that we've drilled our hole, with my drill, now that we have drilled our hole through the chassis, I didn't want to get my table all messed up. Right? We drilled a hole through our chassis. So now we're going to come back, and the tip of this drill, hopefully you can see that, the tip of this drill is the same size as the hole we just drilled through the chassis. And this is a 90-degree, this is a 90-degree countersink, okay? And 90 degree is what's on the back side of a metric screw, okay? That's 90 degree, not 82 like a standard screw. So what we're gonna do, we screwed that on, we drilled our hole. Now we're gonna remove our drill guide, okay? I'm gonna do it so you guys can see it. Of course, I'll have the right side. Am I in your way again? I am. Ugh. I'm working on it, guys. I'll do it like that. Now you can, and you can throw these included screws in your junk screw drawer like that. You're done with this, and see, we got a nice little hole right in between those holes, dead in line with that hole. And what we're going to do is we're going to very carefully use this countersink drill, center drill. We're going to very carefully use safety glasses. We're going to very carefully, I'm going to do this right on my table. I would normally probably do this on the floor, but I want you guys to see what I'm doing. So, I wonder if I got something else to stabilize this thing. Good old Matt. Officer Matt hooked me up with these things, and they are handy dandy. Alright, what I need. I'll fast forward through some of this with you. I just want the chassis kind of flat so you can see what I'm doing, because I want to do this part on camera. Because what we're going to do is we're going to very slowly make this countersink. Super easy, super slow. Now, once you can see the side of the countersink going into the drill, all right, check it with a screw, a 3mm screw. You don't want to screw this up and drill all the way through your chassis. So you see how easy that was? So look, I'm below the screw head, right? The screw head is below because you don't want it scraping on stuff. So you're going to want to go about that deep. Once you can start to see, I'm hoping I can find the right spot. Once you can see the side of the countersink is below, you'll know that the screw will be below the surface. And that's what you want. So I'm going to dump these chips off, and then here, I'm gonna go off camera, clean this little mess up so I don't grind this into my table surface. Hold it tight. Okay, got that little mess cleaned up. I'm kind of anal about stuff like that. I don't want to grind chips into my table. So now we're done with the special countersink drill. Okay, we can put that aside, save that for later, because now you know how to drill and countersink a hole, and you have the equipment to do it on the fly. You always want to make sure you're putting it in the right place, of course. Now, let's flip this sucker over and see if it worked. I'm missing the one piece because I took this piece apart. So let's go ahead. Go ahead and pop a couple of screws in here. Because we're going to reassemble this sucker real quick here.
Okay, I'm excited about this new angle. I think it's going to work out really good. So, put our motor back on. And let's put our screw back in. We're just going to leave this guy loose for now. We're just going to leave the motor slide loose for now because I ain't even got a gear on it yet. Okay, so let's grab a chair. So now here's how it's assembled. Oops, wrong motor. But this is for the 5690. This ain't gonna work on the 5687 because where the wires come out is clocked differently. And you can also see that the 5687 has a central port down here. This is an old motor. I'm designing this thing for the 5690, and the 4990 will be the next one. Okay, so now I believe we're just right. I'm gonna try to zoom in on this thing as when we get to this portion of the video, and I'm going to do my best to keep my hands out of your way. Oh yeah, that's looking really, really nice. Now that's all the way in, and I've already confirmed that an 18 gear is the minimum. I don't have one here. I don't have an 8mm shaft with an 18mm gear. Oh, here's a Mod 1 gear. That is a 13. Let's check this one out. What's this one? This is a 20. Okay. Ooh. All right. Oh, man. Okay, we got some work to do because my holes aren't lining up with a 20 slide. And I know you guys are gonna want to use smaller pinions. So I missed. So look at all that hard work I put in, and then I missed. Things happen. So I'm gonna get it to where it has a little more travel on the 20 pinion, and then when I get back to this point, we'll resume. But for now, the rest of this installation only consists of bringing the screw in from the bottom and putting the slide block on. Oh, that's a bummer. I thought I had that darn thing eyeballed. I really did. I thought I had that darn thing eyeballed, and I did not. Sometimes you miss, guys. It's irritating, but I don't know. Go further with 2 screws in it. I need another 3mm screw. Let's see. Probably should get a shorter screw. We might still be okay. I need the just right size screw though. Maybe that one. Maybe that one there will be just right. Let's bring you guys off the table. Oh. Let me see. Let's see. That is slid all the way in. So now we got to make a judgment call on what we're going to do here. So I need to get that thing bolted down there. So, okay, we are going to consult the test team and see what they think. If 20 minimum would be sufficient. I don't think so. I think I'm gonna have to do a little bit of redesign work. So I'm gonna go redesign the slide block, and I'm gonna add some more travel to it, and then we'll be back. So we're back at it. Now, I just went and ordered an 18 tooth pinion, and it turns out that an 18 tooth is the smallest we can go. All right, and an 18 tooth, the root of the gear is the same size as this shaft. So what I'm doing for now, just to get us in the range, because it's not going to be here till Monday, and I'm going to continue working. So what I'm doing now is I'm going to butt up. I don't think it's necessary to draw a gear to do this when I'm going to have one on Monday, but I'm going to butt this thing up to here, and we're going to see where we're at over here. So it looks like we're about, you guys can't see that. There it is. Looks like we're about a half a hole out. All right, that's a 125 hole. So I'm thinking I need to move about 70 thou, just so I got a little bit of extra room. So what I'm going to do is I'm going to move these two holes over 70 thou, and I don't have to redesign the clamp and the block and everything, because it's pretty tight in there. As you can see, these holes are just barely on the edge of intersecting with those slots. And remember, earlier we decided that we were going to have about 10 millimeters of travel right there. So all that stuff is really tight in there. So what we're going to do, like I said, we're going to move these two holes 70 thou over to push this closer to the center of the truck while still maintaining our maximum and minimum adjustments. Stay tuned. We're back. We are back. We have got, we've got Rev B printed out. Let's put some screws in her. And see how we did. I think we're going to be all right. I got faith in it. I can't believe I missed that. I missed too. So, what do we always do? We always start all the bolts first. That's the way I like to do it. Anyway, that's Rev B. What I did is I moved these holes over 70 thousandths, and that's going to let me bottom out the slide. I'm not even going to worry about this 20 tooth. I'm just going to bottom out the slide. So, we're back to our test fit up. And we are there. Bam. So, yeah. So this shank is 0.632, which would be 16 millimeters, which with an 8 millimeter shank, with an 8 millimeter shank coming out of the motor and a 4 millimeter set screw, that would be a 16 millimeter. So that does not clear the gear at 16 millimeters. If you tried to use a 3 millimeter screw, a 3 millimeter set screw, I mean, in theory, I guess you could, but your customers are not going to be happy. Trust me, because that little 3 millimeter screw is gonna strip out. I guarantee it. Even the 4mm screws strip out. So we are a go. Very nice. And that is also where the slide bottoms out. So let me get you guys up on here. So we're good to go now. We are where the slide bottoms out in the motor mount, and we're on the side here on our screws. Rev B is a go. So yeah, I got to scrap 10 of these Rev A pieces. That's a bummer, but more of a bummer is the time we spend on it, because time is money. We got to get this stuff out to market before somebody else sees it and copies it. I should probably cut that part out. So if you made it this far and you watched the whole video with me, I really want to say thanks for hanging out with me. So let's go check out our end result after we made our modifications and we made all our little pieces. I thought I made more videos on the way. Turns out they were just pictures. You live and you learn, right? So let's go check it out, guys. That's the 18-tooth pinion on there. And we're maxed out on our adjustment. Actually, the maxed out on the adjustment will go slightly lower than this, but you can see how an 18-tooth gear pinion, the root of the 18-tooth gear pinion gear, you can see that the root is smaller than the 16mm shank, and you're not going to want to. Nobody's going to make a smaller shank. Maybe somebody makes a 12. You never know, but it ain't going to fit this application. So we are there. We are ready to roll. I sent this out to a couple of test guys, and they're going to give me their opinions on it, because I never bring anything to market without running it by the guys. All right. So it is New Year's Eve on 2025, and I want to thank you guys for hanging out with me all this year. Please like and subscribe to my YouTube channel, M2C Racing, and thanks so much for hanging out and coming along with me. We're going to do a lot more videos this year, and we're going to have a lot of fun with a lot of new products. So come check us out at www.m2cracing.net and get you some awesome parts right now.